Hello, and thanks for clicking on this next Prenarculus production. Today, we're going to be talking about the sum and difference formulas, how we're going to use these formulas, what they are, what they'll do, and what they'll accomplish. All right, so it's not that complicated, but let's get started and let's see how we can use these items. All right, so let's say we wanted to find an exact answer for the sine of 75 degrees. Now, you might be saying, okay, well, we can type this into the calculator, and you would be right. We could. Okay, it would give us a decimal answer, but it wouldn't give us that exact answer with radicals and anything else that we can think of in it. All right, now the only problem with 75 degrees, and we know the sine's the y coordinate, but 75 degrees doesn't show up on the unit circle, right? It's not one of our special angles that are on that unit circle where we know the exact values. So what we have is we have these formulas called the sum and difference formulas. The sum and difference formulas, we can use these to take two angles that are on the unit circle and add them together to create the exact value for a non-unit circle angle, like 75 degrees. All right, so down below, you see one of these formulas. We're going to learn how to use these formulas here. I'm not going to prove to you the rules. It's a fairly complicated geometric proof as to where the rules actually come from. So I'm going to show you what the rules are, and we're going to learn how to use them and use them effectively. Okay, so suppose u and v are two different angles. Then to find the sine of u plus v, meaning I want to add two angles together and do the sine of it. To do that, you need to do the sine of the u angle times the cosine of v plus the cosine of u times the sine of v. So it's a fairly complicated formula here to do something that seems like it should be pretty simple, but that's the way it works sometimes. So let's try to find the sine of 75 degrees. So let's see how this would work. I want the sine of 75 degrees. Now, the first thing I got to do is I got to find two angles off the unit circle that in this case will add together because that's the only formula I know. There's also one for subtraction. There's one for all of the trig functions, and we'll talk about them on the next slide. But I want to find the angles that add together to be 75 degrees. But again, I want to be strategic in my choice. I want to pick angles that are on the unit circle that I know the value of. So the easiest way to do that, I think, is to do 30 degrees plus 45 degrees because I know that's 75 degrees. So what I'm going to do is I'm going to use my formula here, and I'm going to find the sine of 30 degrees plus 45 degrees. So that makes u 30 and v 45. So I'm going to plug them into my formula over here, and I'm going to find the sine of 30 degrees times the cosine of 45 degrees plus the cosine of 30 degrees times the sine of 45 degrees. And now I'm going to work on the right-hand side here. 30 plus 45 is 75. So I know the sine of 75 is going to equal whatever all this is as I calculate it. So sine of 30, sine's the y coordinate. The y coordinate there is 1/2. Cosine of 45, cosine's the x coordinate of 45 degrees, root 2 over 2. Plus cosine of 30 degrees is root 3 over 2. Times the sine of 45 degrees is root 2 over 2. So if we're going to multiply now, we're multiplying two fractions straight across. 1 times square root 2 is square root 2. 2 times 2 is 4. And then square root 3 times square root 2, I can multiply them. They're both in a square root. I get square root 6 over 4. The denominator is already common, so I can just add the tops, but I really can't add them because they're different radicals. So I now know that the sine of 75 degrees, its exact answer is square root 2 plus square root 6 all over 4. And that is the correct answer for the sine of 75 degrees. Okay, that's how we're going to use these formulas. All right, so let's take a look at the other formulas. I'll give you a way that you can remember some of them, kind of make your life a little easier, and we'll go from there. All right, so here are the two formulas for sine. You can take two angles from the unit circle and add them, or you can take two angles from the unit circle and subtract them. The formulas are slightly different, almost the same, okay? And then the cosine of u plus v, versus the cosine of u minus v. And then we have two formulas for tangent as well, adding two angles and subtracting two angles. So the easiest way to remember these, I think, is there's a little phrase that you can use, SMS. So it means for the sine, the formulas for sine, you mix the trig functions, sine and cosine, mix them together, and then keep the same sign, as in SIGN. Okay, so sine of u plus v has a plus in the middle, and I mix the sine with the cosine. All right, for cosine, we use CGO. For cosine, you group the trig functions together. So group cosine with cosine, sine with sine, and use the opposite sign of the original. So cosine of u plus v, you use minus in the middle. And for u minus v, you use plus in the middle. Okay? So that's how you would remember cosine. And then for tangent, well, tangent, the sign that's here stays consistent up top, and then on the bottom it switches. So whatever sign you use up top, use the opposite one on the bottom. And same thing here, minus here, minus there, plus on the bottom. All right, so let's take a look at how we can use these. We'll use it both in degrees and radians. Let's try to find the exact value of cosine 15 degrees. Okay, so the first thing we need to do is we need to figure out a way to write 15 degrees using the unit circle. Okay, angles from the unit circle. So there's a lot of ways that you can actually do this, believe it or not. I'm sure maybe your first instinct is 45 minus 30, which is not a bad instinct. That would work. I'm going to pick something else just for the sake of picking something else and showing you that it'll still work. I'm going to do 135 and 120. So both of those are on the unit circle, so that should work. To find the 15 degrees, I am subtracting, so I want to use the formula for cosine of u minus v. So I'm going to do CGO. I'm going to group them. Cosine u, cosine v. Use the opposite sign. It's minus there, so I'm going to use plus. Sine u, sine v. Okay, so I'm going to find the cosine of 135 minus 120. So that's cosine 135 times cosine 120 plus sine 135 times sine 120. All right, and that's going to be cosine 15. So cosine of 135, cosine is x coordinate. I'm in quadrant 2, so it's going to be negative there. It's negative root 2 over 2. Cosine of 120, 60 degrees is the reference angle. I'm in quadrant 2, negative 1/2. Plus sine 135, I am in quadrant 2 again. Sine is the y coordinate, it's positive there. So that's root 2 over 2. And then sine of 120 is going to be root 3 over 2. So if I negative times negative is positive, root 2 over 4 plus root 6 over 4. My denominators are the same already. So I get root 2 plus root 6 over 4. That is the cosine of 15 degrees. Okay? That is the cosine of 15 degrees. Now, if you notice, it happened to be the same as sine of 75 degrees that we did on the first slide there. But remember, that should make sense to you still, because 75 and 15 make 90, and sine and cosine are cofunctions. So cofunctions, right, of complementary angles are equal. So these two answers should have come out to be the same. Okay? All right, let's try it with radians. We're going to try to find the sine of 5 pi over 12. Okay, now in radians, I guess it's a little more complicated because the issue is there is no over 12s on the unit circle. So what you should do is to make 5 pi over 12, the easiest way to do it, I think, is to keep denominators with 12s, make them, the numerators add to 5 pi, and then reduce to make sure that both of those angles are on the unit circle. So I'll give you an example. Let's say I tried 4 pi over 12 plus pi over 12. 4 pi and pi is 5 pi. 4 pi over 12 reduces to pi over 3. That's on the unit circle, but pi over 12 is not. So that's not going to work. I can't use 4 pi over 12 and pi over 12. I got to try something else. So how about 2 pi over 12 and 3 pi over 12? So that would be, reduce that, makes pi over 6. That's on the unit circle. 3 and 12, 4. Pi over 4. That's on the unit circle. So this will work. So 5 pi over 12 is pi over 6 plus pi over 4. Both on the unit circle, so we can do it. We're doing addition here, right? Adding. So we're going to need the sine of u plus v. So the sine of u plus v, sine, we mix them and keep the same sign. So that's going to be sine u cosine v plus, keep the same sign, cosine u sine v. All right, so that's sine of pi over 6 plus pi over 4. So that's going to be sine of pi over 6 times cosine pi over 4 plus cosine pi over 4 sine pi over 6. So sine of pi over 6, that's 1/2. Cosine pi over 4 is root 2 over 2. God, it feels like these answers are familiar again. Cosine of pi over 4. Oops, that should say cosine pi over 6. Sorry. So this should say cosine pi over 6 sine pi over 4. Yeah, that makes more sense. Okay, so cosine pi over 6 is root 3 over 2. And sine pi over 4 is root 2 over 2. So that gives me root 2 over 4 plus root 6 over 4. Feels like this is the only answer you get. Root 2 plus root 6 over 4. That is the answer for sine of 5 pi over 12. Now you might be thinking, well, we got the same answer 3 times. Well, the problem is we've done the same problem 3 times. If I were to take 5 pi over 12 and multiply by 180 over pi to put it in degrees, let's see. We know 6 goes into both. 6 goes into 12. Actually, 12 goes into both. 12 goes into itself. And then 12 goes in here 15 times. So 15 times 5 is 75 degrees. So I just found the sine of 75 degrees. I did this on the first slide. Okay? But this is how you would do it if it were in radians. All right. This one's going to have a different answer, I promise. Let's try to find the tangent of 7 pi over 12. Okay. So again, 7 pi over 12. I got to try to use over 12 as my denominator. Got to add up to 7 pi or subtract to be 7 pi. Either way, I like to make them add up to that, but it doesn't matter. So I'm going to use 4 pi over 12 and 3 pi over 12. I think that'll work. Yeah, so 4 and 3 make 7. 4 goes into 12 3 times. That's pi over 3. And then that's on the unit circle. 3 into 12, 4. Pi over 4, also on the unit circle. So we're going to do it. Tangent of pi over 3 plus pi over 4. For tangent, the numerator is added or subtracted depending on what this sign is. So we keep the sign. So it's tan u plus tan v. The denominator is 1 minus, it's the opposite sign of what's up top, and then I multiply tan u times tan v. Okay, so this one's a little more complicated. So we're going to have tangent of pi over 3 plus tangent of pi over 4 over 1 minus tangent of pi over 3 times tangent pi over 4. All right, tangent of pi over 3. I'll do it over here. Pi over 3. My point of pi over 3 is 1/2 root 3 over 2. Tangent's y over x, or sine over cosine. Root 3 over 2 over 1/2 is root 3 over 2 times 2 over 1, which is root 3. So this is root 3. Tangent of pi over 4. That's 1. Over 1 minus tan pi over 3 is root 3. Times 1. So this is root 3 plus 1 over 1 minus root 3. Now, you can rationalize this. You can multiply top and bottom by 1 plus radical 3, multiply by the conjugate to remove the radical in the denominator. So if I multiply across the top, I get root 3 plus root 3 times root 3 is root 9 plus 1 plus root 3, 1 root 3. On the bottom, I get 1 plus root 3 minus root 3 minus root 9. So if we clean this up a little bit, we get 2 root 3 on the top. Those two combined. Square root of 9 is 3 and 1. That makes 4 if I finish up the top. On the bottom, these cancel. 1 minus 3 is negative 2. And then I can take out a 2 and knock out the 2 that's underneath. So 2, cross it out. I get negative root 3 plus 2. And that's my answer. I'm all done. Okay? So that's it for that one. And let's take a look at one more, which is a little different. No, two more, sorry. Cosine 140 times cosine 40 minus sine 140 times sine 40. All right, so you might be looking at this and saying, well, 140, it's not on the unit circle. 40 is not on the unit circle. How am I supposed to do this? We're going to use the identities in reverse. Look at the right side of your identities and show me which one matches what we're given and what you're supposed to get on the left-hand side. So this is, if we look at it, cosine u cosine v minus sine u sine v. That one matches cosine u plus v. Okay, u plus v, right? So what am I asking you to do? I'm asking you to make u 140 degrees, v 40 degrees, and find for me the cosine of u plus v. So that's the cosine of 140 plus 40. That's the cosine of 180. The cosine of 180 is negative 1, and that's the answer. So you can also use these from right to left as opposed to left to right. And then finally, let's say I were to tell you the sine of u is 7 over 25 if u is between 0 and pi over 2, and the cosine of v is negative 4 over 5 if v is between pi over 2 and pi. I want you to find for me the sine of u plus v. So you're going to look at this, and you're going to say, well, wait a minute, 7 over 25, that's not a ratio off the unit circles. Neither is negative 4 over 5. Well, if it's not a ratio off the unit circle, how do we work with this? We make triangles for it, and that's what we're going to do. Okay, so let's write it out first. The sine of u plus v is sine u cosine v plus cosine u sine v. Okay. All right, so that's what we're going to look for. We need to find sine of u, cosine v, plus cosine u, sine v. Now, some of them are already given up here, but I need to find the other ones. So sine of u is 7 over 25, and u is between 0 and pi over 2. So I'm going to make a triangle in quadrant 1. Here's angle u. Sine is y over r. So y is 7, r is 25. You can either use the Pythagorean theorem or it's a Pythagorean triple. This comes out to be 24. Okay. And then cosine v is negative 4 over 5. V is between pi over 2 and pi. So v is here in quadrant 2. So let's make our triangle here in quadrant 2. Cosine is x over r. R has to be positive. X is negative. That makes sense. We'd have to find y, but it's 3. It's a 3, 4, 5 right triangle. And here we go. So the sine of u is given. It's 7 over 25. Just write it down. Cosine of v, also given. Negative 4 over 5. plus cosine u. Cosine is x over r, 24 over 25. Using our triangle. And using our v triangle, sine v is 3 over 5. I highly suggest you label your triangles as well, u and v. You'd be surprised with the number of people who have the correct triangles and then they use the wrong one to find one of these values. So I highly suggest you label which one's which so that you definitely know which one you're working with. Okay? You don't want to make a silly mistake like that. All right, so now that's negative 28 over 125, right? 5 quarters is $1.25, plus 72 over 125. So 72 minus 28 is 44, I think. Yeah, 44 over 125. I can't reduce that. That is my answer. Okay, and that's it. That's how we use these sum and difference formulas. And as always, thanks for clicking.